recording. So fractions are always difficult, right? So it says x is 5, y is 2. So I have 3/4 times 5 plus 1/4 times 2. And, okay, now I'm multiplying fractions, right, Jordan? I see an addition, but I have to do my multiplication first. If I don't have a denominator, I can create one, right? So, the numerator, 3 times 5 becomes 15 over 4 plus 2 over 4, which gives me 17/4, I think. I don't know what they had in the back. I could write that as a mixed number, but I prefer, let's see what they had in the back. Yeah, 17/4, right? Yeah, so just remember, if you don't have a numerator, if it's a whole number digit without a numerator, just, the denominator just becomes 1. Okay? Anything else? No? Okay. I wish you guys were noisier. I really do. All right, let's start solving equations. We did talk a little bit about equations. What Eunice showed us yesterday, when she showed us her way to calculate the number of brochures, that was actually using algebra, which is solving equations. We're going to start solving one step, and then solving one step lays the foundation for solving any number of steps, really. We're going to tackle 1- and 2-step equations in this class. So this is a very valuable algebra skill. There are lots of times in your life where you have to solve an equation, even out of school. So we're going to solve one-step equations. We're going to verify. Verify is something important in math. It means the word verify, verity is the truth. So it means to prove to check your answer. That's what it means to do, to check your answer. Check your work, check your answer. And that's a specific skill as well. And then we're actually gaining these skills so we can actually apply them and start solving problems in context, meaning word problems. All right, so for the first time in this class, we're actually being given an equation to work with. If you kind of just drop your eyes down to here, I think you'll see this is something different than what you were just working on yesterday. Like, can you see the difference between this and this? I don't know. Can you see the difference? What's the difference what's an obvious difference? I saw you nodding your head, Jazz. What's the difference? There's an equal sign, right? So an equal sign, as soon as I put an equal sign here, and I give you a number on the other side of the equal sign, I've given you an equation. These are just expressions. You can even look at the words, right? Determine the polynomial expressions. We actually make an equal sign here, right? And we're going to write the answer down, but you're not solving anything, you're simplifying. So we simplify expressions, we solve equations. And equations open up a whole new area to us. To solve an equation means to find the number, to find the variable, or the identity of the variable that makes the equation true. Or, in other words, to make both sides of the equation equal each other. There's one perfect value in the types of equations that we're going to be talking about today that makes both sides of the equation equal each other. So our whole goal is when we find that perfect value, the solution, the left-hand side will equal the right-hand side. Okay? Now, we're going to start off really easy. You can solve these, we say, by inspection, right? I'm sure you guys know what the identity of x is, right? X plus 2 is 9. What's x? What does x have to be? 7, right? So we do that by inspection, but we're going to go through the motion on a very small scale, so that when the questions and the equations become a little more complicated, as long as we stick to our procedure that we used on these baby equations, we should be able to solve really complex ones. So what we do in math and in science, they handle things sometimes a little different than we do, but we get the same result. When we solve an equation, we isolate the variable. So that's what we do in math. We isolate the variable, the unknown, so that it's sitting by itself on one side of the equal sign, and we're going to practice solving some simple equations. Now, first of all, This equation has two sides. Sometimes they're referred to or they're shortened as LHS and RHS, right-hand side, left-hand side. So you can see you were given an equation. These are both polynomials, agreed? X plus 2 is a binomial, 9 is a monomial, it's a constant. So we're still in the world of polynomials, but they've become much simpler. Would you agree? Very simple, no x squareds or anything like that. We will be solving x squareds soon enough, but we're going to start really small. So I'll just show you how I'm going to introduce equation solving to you. And again, I know you come from very different backgrounds, and you might have different ways to solve. As long as you're coming up with the right answer and your answer verifies, whatever method you use is fine with me. But for students who are just starting back in school or who have don't remember doing this, I separate my sides to denote that there are two sides, because it makes a difference what I do to one side, what happens to the other side. So I want to make sure that I keep reminding myself there's two sides. I look at the side where x is, because this is the variable I want to know the identity of, and I'll know the identity of x, I'll know the value when he's isolated. Right now he's attached to the 2, agreed? This statement is x plus 2. He's attached to the 2 with addition. So every math operator has an opposite operator. So what's the opposite of adding? Subtract. So I have to subtract this 2 out, and I'm allowed to do that as long as whatever I do on one side of the equation, I do to the other side of the equation. Okay? Plus 2 minus 2, what happens to a positive 2 minus 2? 0, right? Your calculator will even tell you who the inverse partners are. Most calculators are set up like this. Any decent calculator, plus and minus undo each other. And remember this for a little bit. Multiply and divide undo each other. Okay. So if I had a positive 2 in my calculator and then I subtracted 2, it just zeroes out, right? So I'm left with x plus 0, which is just x. Okay? 9 minus 2 is 7. And once again, I know all of you could have just told me the answer by looking at it, but we're developing a system, right? Now it says verify the solution. To verify means to check my answer. And again, you're probably doing this in your head, which is awesome if you can think abstractly in your head. But to verify is a little different than solving. It kind of starts off the same. What we do to verify is substitute, that skill we were just doing yesterday, substitute the value x equals 7 into the original equation. Okay, so I say x is 7. Well, let's check it out. 7 plus 2. My right-hand side, I had no variables, so it just stays as 9. And I simplified the expression, right? 7 plus 2 is 9. 9 equals 9. I have verified. Once you've proven that left-hand side equals right-hand side, you've verified. So we're using that substitution skill, okay? Questions? And like I say, I'm sure you've learned, if you've learned another method, that's fine. Verifying, though, there's really no other way to do verifying. That's what verifying is. Okay, let's try the next one. X minus 12 is 31. All right, I look on the side where x is, because, by the way, it won't always be on the left-hand side. Okay, x subtract 12, opposite of subtract is add. Okay, so x equals 43. Right? I'm going to verify. So I had 43 subtract 12. It should equal 31. I can use my calculator if I have to. 31 does equal 31, so we verified the equation. Left-hand side equals right-hand side. So you know your answer is good. like I said, I wish you guys could talk a bit more, ask questions, talk to each other more. So if I don't hear talking, I just keep going, and I don't know if that's necessarily the best thing to do. Let's try the next one. 54 plus x is 75. What side is the x on? Yeah, left-hand side. How is it attached? Is there a number attached to it? Yeah, 54 is attached to the x, right? It's attached with addition. So I have to subtract my 54. And I'm going to get x equals 21, right? You don't sound convinced that the answer is 21. Is it? Okay. So let's verify. 54 plus 21. It should equal 75. Okay. Yeah. So verified. I'm going to add a couple of more difficult ones onto this in the end too. Okay, 122 plus x. Tell me what the answer is. I'll give you, not right now, but give everyone a few seconds. Okay, what's the answer? 31? Negative 31, right? Okay, so I have to subtract the 122. So x will equal negative 31. But we know negative numbers exist, right? We've worked with them a lot in that first unit. So let's verify. 122 plus negative 31. Multiplying a positive times a negative gives me a negative. So I get 91, which is my right-hand side. So we verified. Okay. Yeah.
Miss, I took the 122.
Yeah, and you got to be careful.
No, I kept, no, I took the x the other side and became a negative.
Yeah, so then you're running into bigger problems there, right?
And then
There's a way to get around that, but
I divided it by negative 1.
okay. Did you get negative 31?
Yeah,
Okay.
because I divided it.
Okay. How about this next one? X is on the right-hand side. That's fine. It doesn't matter where X is. It can be on right and left. There's no side that it has to be on or end on. It's nice when X is positive, that's for sure. But okay. Any takers on the answer? 543, right? Subtracting a 24, it's a positive 24 added to x, so we're going to take that away, and we'll verify this one. 567 on the left-hand side, 24 plus 543, and that adds up to 567 for sure. Yeah? Are we good with this? You guys Is this like really, a really easy review for you right now? So far? Okay, all right, how about I give you a couple minutes just to walk around and do the questions on the following page 25, and then we're gonna take a quick, I'll share the answers with you, and then we'll, and it doesn't say to verify, so you could verify, you don't have to formally verify a guess, but you could use your calculator to verify. I'll record the answers in 1 minute or after a few minutes, and then as long as you guys are okay, we'll move on to the next part as well. Okay, the answers are in the back. I wasn't sure if they were, but they are in the back, so you can check your work. Okay, you guys ready to move on? Anything that you got stuck on, or are we okay with? All right, let's talk about, we're still doing one-step equations, but now we're going to use multiplication or division. And they're approached the very same way, but this time the x is attached to a variable through multiplication or division. So we follow the same kind of reasoning as before. I look at how the number is attached to the x, and I have 3 times x equals 12. Agreed? So how do I undo multiplication? Divide, right? I'm going to show my divide this way. I know there's not lots of ways, but I'm going to show divide by putting a division bar like that. So whatever I do to one side, I do to the other. So literally, 3 divided by 3 is what? What's 3 divided by 3? 1x equals 4. And we don't write the coefficient ever, right? If it's a 1, so we just say x is 4. Should we verify? Okay, I'm going to verify my solution. So then 3 times 4 should equal 12, and it does. Next one, 28 equals negative 4 times x. So here's where x is. It's attached to the negative 4 by multiplication again. So I undo multiplication with division. This time I have to divide out a negative number. Whatever I do to one number I do, or one side I do to the other. Negative 4 divided by negative 4 again is 1x, but I never write the coefficient of 1. So 28 divided by negative 4 is negative 7. So we'll verify that. Negative 4 times 7, sorry, negative 4 times negative 7. A negative times negative is a positive, so I get my 28 equal to 28, so I verified that as well. X divided by 5 equals 3. My x is on the left-hand side this time. X divided by 5 equals 3. The opposite of division is multiply. So I'm going to show my brackets with, my multiplication with brackets. And notice where the multiplication goes, it goes up top, right? It operates very similar. Remember when we had a multiply, the division is on the bottom. Right now the division's on the bottom, so the multiply shows up on top. So we get this 5 divided by 5, which is 1x. 3 times 5 is 15. So I'll check. 15 divided by 5 does equal 3. Okay, questions? Same procedures, right? We're just undoing whatever operator the number is attached to the x with. And then that's leading up to some word problems, which I don't think these are that challenging, but they are introducing us to the fact that we're basically going to be applying our knowledge sooner or later. So 1/3 of Ken's cousins attend his hockey game. 8 of his cousins attend the game. So I guess that 1/3 of his cousins equals 8. So use the equation x over 3 equals 8 to answer the following questions. Solve for x. Okay. Now, remember that x over 3 equals 8 can also be written as, or thought of as, 1/3 x equals 8. Right, 1/3 times x. I would have, I guess, a 1 on the bottom. So 1 times x just becomes x. 3 times 1 becomes 3. If I just put it in, it helps put the question in context a bit better, right? Because it said that 1/3 of Ken's cousins attend his hockey game. 1/3 ends, that would be 8 of his cousins. So 1/3 of x equals 8. All right? This is a nicer form to solve it in, though, right? This is a nicer form to think of the whole question in context. So, what am I going to do? I'm going to multiply both sides by 3. And I get x equal to 24. So what does 24 represent in this problem? Total number of his cousins, or 1/3 of his cousins. It represents the total number of his cousins. Because literally we took 1/3 of that total and found out that there was 8 of them. So x is the total. So now you can see it's starting to slowly come together, right? The skills we were learning or reinforcing and why, and then substituting into values, because they're eventually going to help us solve larger, more complex questions. So we have example 6. The following formula gives the ideal amount of sleep needed each night by people 19 years or younger. That actually is a formula that came out from somewhere. I'm not sure if it's still valid. So if you're 19 years or younger, you might want to pay attention to this. So H represents the number of hours of sleep, and A represents the age in years. So we've got 2 variables in this question. Typically, if we're asked to find the value of something or to solve for something, we have to be given, we can't solve an equation with 2 variables, so we'll be given info to substitute in for one of the variables. So let's see what happens. How much sleep does a 14-year-old need? Now remember, this represents the age. This represents the number of hours. So, how much sleep does a 14-year-old need? What am I going to do here? What am I solving for? H or A?
H.
H, right? We know that A equals 14, correct? So if I substitute that 14 in, okay, so this goes back to order of operations. I did say to you that whenever you have a complex fraction, like 2 or more numbers in the numerator denominator, you have to, it's implied that there's brackets around there. So that means that H should equal, well, 35 subtract 14, I get 21. divided by 2. So 10.5. Are you guys shocked at that? I know there's some under 19-year-olds here. And I'll bet you that you don't get 10.5 hours of sleep. 4? Why 4? That's how your life is set up? You can only get 4 in? Are you tired during the day? Oh. How many people get 10 hours of sleep here? It's supposed to be very good for you to get good. Sleep is how you restore your body, right? Okay, what about this one? Jasmine's 10. She gets 9 hours of sleep each night. Is this enough? You tell me. Why do you say no?
She should get 12.5 hours.
How'd you get that?
What's that?
How did you get that?
35 minus 10 divided by 2.
Okay, you just substitute A is 10, right? So you figured out how many she should be getting. So 35 minus 10 divided by 2. So we get 25 divided 2, which is 12.5, right? So the answer to the question is, as Alex said, no. She needs 12.5. Okay.
But how do you get more if you're over 35?
I don't have that formula. I'll try and find it though. Every day it seems like there's a new study about sleep, but I've always heard that it's between 8 or 9 for adults. If you for long term too, right? And if it's less than that, you can suffer sleep deprivation, right? All right, so you've got this assignment to work on. Maybe it's not that challenging to you, but do it. I mean, if you find it really super easy, do a couple. If you're fine, that's good.
Which one?
Assignment 6. I do have one more little thing that I want you to do for me at the end before you go. It's not worth a lot of marks. I don't even know if it's worth marks. I just want to challenge you guys. I'm going to write something on the board. It's kind of like one of those problem things. But I'm just going to tell you right now, there's there's infinite number of answers. So there's not one right answer. Okay, I want you to think about this. Check it with a partner maybe before you hand it in too. Check it with someone besides me. And you can just write it on a piece of scrap paper if you need scrap paper. I have scrap here too.